Australian scientists just announced the world's first working proof of concept quantum battery. Not a theory, not a this might work someday paper. A real device, one day built, charged, and pulled energy out of. I'll be honest, my first reaction was skepticism because we've all seen the headlines. Scientists invent battery that charges in seconds. And then you read it and it's like, it works at minus 270 degrees, only stores enough energy to power a grain of rice, and is a decade away from being real. You know the type, why am I telling you this? But I actually dug into this one and it's different. It's legitimately different, and I want to walk you through exactly why. What it does, who made it, what still needs fixing, because there are things that need fixing, and why I think this is one of those things we're gonna look back on and say, yeah, that's where it started. First, who built this thing? The team behind it is CSIRO, Australia's National Science Agency, working alongside our MIT University and the University of Melbourne. The lead researcher is Dr. James Quach, and this guy has been grinding on this problem for years. The paper came out in journal Light, Science and Applications, which is a peer-reviewed publication. Now here's the thing though, this team actually had a version of this device back in 2022. They demonstrated some of the core quantum charging effects back then, but there was one glaring problem. They couldn't get the energy back out. They could charge it, then they just couldn't discharge it. So that 2022 result was exciting but incomplete. This new paper, however, closes the loop. Charge it, store it, and then use it. A full cycle. That's the milestone everyone in this field has been waiting for. But then there's the second question, and that is, what even is a quantum battery? So let's slow down for a second because I think this part is where a lot of science coverage fails people. They throw the word quantum and then they move on like that explains everything. It doesn't. A traditional battery, like your phone battery or EV battery, works through electrochemical reactions. Ions move around, electrons flow, energy is stored and released. It's a chemistry process. A quantum battery is fundamentally different. It stores energy using the principles of quantum mechanics. Specifically, this device is built around something called superabsorption. The idea is that instead of absorbing energy bit by bit, the way a regular battery charges incrementally, the quantum system absorbs it all at once, collectively, in a single massive event. Every storage unit charges simultaneously, and the result of that is a charging speed that classic physics flat out cannot match. The physical device itself is a multi-layered organic microcavity, and it charges wirelessly, via laser. No cable, no port, just a laser beam hitting the device and loading it with energy. I mean, come on, that's so cool I almost can't stand it. But that isn't even the part that breaks your brain, because this is the detail that got me. Genuinely, because it is so counterintuitive it feels wrong when you first hear it. Quantum batteries charge faster the bigger they get. That's the opposite of everything we know about batteries. Scale up a lithium-ion pack and you introduce heat problems, longer charge times, and more complexity. It gets harder. But with a quantum battery, size is actually an advantage. The quantum effects get stronger as the system scales. Larger batteries charge even faster, not slower. Not the same, faster. Now, if that doesn't make your brain itch a little, think about it again, because that property right there is potentially game-changing for electric vehicles specifically. The very thing that makes EVs frustrating right now, needing a large battery that takes forever to charge, is the thing a quantum battery would be best at. You want it big? Great, it'll charge quicker. That's not just an incremental improvement over lithium-ion. That's a completely different relationship between scale and performance. But I'm sure you're thinking, what did they actually measure? Now I want to get into specifics here because I think the actual numbers are where the story gets really compelling. The team used advanced spectroscopy techniques to confirm how the device behaves during charging, and what they found was that it retains stored energy for 6 orders of magnitude longer than the charging time. That's a factor of 1 million, so if the device takes 1 minute to charge, energy sticks around for roughly 2 years. The measurements were done at the University of Melbourne's ultrafast laser laboratory, using equipment capable of detecting events in femtoseconds. That's 1/4,000,000th of a second. This isn't rough experimental data. This is precision science at a scale most people will never encounter, and crucially, the results matched what the theoretical models predicted. That confirmation, it means the underlying physics isn't sound. But all is not sunshine and rainbows, and this is the part where I have to be honest with you. Right now, the prototype stores only a few billion electron volts. That sounds like a lot until you realize it is nowhere near enough to power anything useful. The discharge duration is in nanoseconds. Dr. Quach himself said it plainly. That is not enough if you want to make a phone call. So, no. This is not going into your next iPhone. Not next year, not in 5 years probably. What this is a proof of concept. It proves the full cycle works now. It proves the quantum effects are a real and measurable thing. It proves the theoretical framework holds up in real devices. That's the foundation. And here's the thing. In July 2025, the same team extended the battery's energy storage lifetime by a factor of 1,000. From nanoseconds to microseconds in less than a year, 1,000 times better. That trajectory is steep, and it's pointing exactly where it needs to go. Now, why the EV angle is huge? The applications here go further than most people are probably imagining. CSIRO had said outright that quantum EV batteries could one day charge faster than the time it takes to fill a petrol tank. Not just faster than today's fast chargers, faster than a petrol station. Think about what that does for the argument against EVs. The number one complaint, charging time, evaporates. The other major advantage is that they're chasing wireless charging over long distances. The laser mechanism isn't just a lab quirk. It's a pointer towards a future where you charge a car, a drone, or a device without ever plugging anything in. Quantum computing. Quantum computers need extremely stable, compact energy sources with minimal heat output. A quantum battery designed around the same physical principles could be easily and exactly the kind of power source those systems need. It's a 2-for-1 that the industry hasn't fully woken up to yet. I follow a lot of science and tech news. A lot of it is noise, incremental improvements dressed up as revolutions. This one genuinely doesn't feel like that to me. The reason is simple. This works at room temperature. This is a massive qualifier. Plenty of quantum phenomena only show up in the ultra-cold, ultra-controlled environments that you'll never recreate outside a lab. Room temperature means the path to real-world application actually exists. It's not guaranteed, but it's real. Dr. Quach and his team didn't just publish an idea. They built a device, measured it, validated the theory, and then they went and made it 1,000 times better within a year. CSIRO is now actively looking for an industry partner to take this further. That's a flag in the ground. That's a team that believes in what they've built and wants to move forward. I believe it too, and I think in 10 to 15 years, we're going to look back at this paper the same way we look back at the first lithium-ion demonstrations way back in the 1970s. Messy, limited, nowhere near ready, but unmistakably the beginning of something that changed everything. This is one to watch, so bookmark it and come back to it, because the next time you hear about quantum batteries, it's probably going to be a much bigger headline than this one.